Chapter 5, Lesson 2, Sequences. Describe and extend sequences. In an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. So it says, number 1, describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23, then write the next 3 terms in the sequence. So when it talks about describe the relationship, it wants to know what is happening. What are we counting by in an arithmetic? So what I do is I always take the first 2 numbers. So I have 8 and 13. So I take 13 minus 8, and I get 5. I go to the next 2. I take 18 minus 13, and in this case I get 5. And then 23 minus 18, I get 5. So I know I am counting by 5. So my numbers are getting larger. So the relationship is add 5. So if I'm finding the next 3 terms or the next 3 numbers, I'm going to take 23 plus 5, which is 28. 28 plus 5, which is 33. And 33 plus 5, which is 38. In example 2, it says describe the relationship between the terms in the arithmetic sequence 4/10, 6/10, 8/10, 1 whole, then write the next 3 numbers in the sequence. So again, I'm going to take the first 2 numbers, 0.6 minus 0.4, I get 0.2. If I take the next 2, I have 0.8 minus 0.6, I get 0.2. So I know that what I'm adding or my counting by is 2/10, 0.2. My numbers are getting larger, so I know I'm adding 0.2. That's my relationship. So then what are the next 3 numbers? Well, I have 1 plus 0.2, which is 1.2. 1.2 plus 0.2 is 1.4. And 1.4 plus 0.2 is 1.6, or 1 6/10. We're simply adding that number, our relationship, to each one to continue on with the pattern. So here's 2 more got it problems. We're going to, again, describe the relationship and then write the next 3 terms. So for letter A, I have 13 minus 0 is 13. 26 minus 13 is 13. So since my numbers right here are the same, I'm going to stop. So my relationship is plus 13. My numbers are getting larger. So the next 3 numbers would be 39 plus 13, which would be 52. 52 plus 13 is 65. And 65 plus 13, which is 78. So for letter B, I have 4, 7, 10, 13. So again, I do the same thing. I take the first 2 numbers. 7 minus 4 is 3. I take 10 minus 7, that's 3. So I know my number is 3. That's the relationship. So I'm adding 3 each time. Notice that my numbers are getting larger, so it's addition. So then to find the next 3 numbers in my term, I take 13 plus 3, which is 16. Add 3 is 19. Add 3 is 22. So here's an algebraic expression or sequence. If the pattern continues, what algebraic expressions can be used to find the number of total circles in any figure? How many circles will there be in the 50th figure? Well, in figure 1, I know that there's 3. Figure 2, I know there's 6. figure 3, there is 3, 6, 9. So what can I write for an algebraic expression? Well, I know if the figure is f, I know that if I take 3 times f, whatever the figure is, I know I get that many circles. So my algebraic expression is 3f. That means 3 times whatever figure it is. So then to find the 50th figure, I'm simply going to take 3 times 50 to get 150 circles. So my example number 4, it says Hannah has a doll collection. The table shows the number of dolls she bought the first 3 years. So the first year she bought 6, the second year she bought 12, the third year she bought 18. Write an algebraic expression to find the number of dolls in her collection after n years. Well, if we go to n years, I know that I'm always adding 6. So because we're adding 6, that means to find the number of in n years is going to be 6 times whatever year it is. So again, that is my algebraic expression. Now, if we want to know how many dolls Hannah will have and how many dolls will Hannah collect during her 25th year, then I need to take 25, which is my n, and then multiply that by 6. And 25 times 6 is 150 dolls.